Hi, Professor. This is Sue, Joey, and Olive. Welcome to our ICDS final project. In general, we upgraded the basic chat system into a versatile interactive chat platform, where we first built the chat system's foundation with a layered architecture. The first one, GUI for interaction, client for local logic, and server for global communication. Based on this structure, we implemented 6 core features, including GUI snake game plus ranking list, chatbot with personality modes, emoji, NLP, and sentiment analysis. And now, please watch our wonderful demo.
For emoji support, we implemented a client-side picker that requires no server changes. The system adds an emoji button between the message input and send buttons. When clicked, it opens a pop-up window displaying 48 emojis in an organized grid. A key design decision was keeping the window open after selecting an emoji. This allows users to insert multiple emojis without reopening the picker. Emojis insert at the current cursor position, providing flexible placement within messages. This also maintains natural workflow while enhancing expressiveness in chat. The implementation adds just 2 methods to GUI.py, one to create the emoji window and another to handle insertion. The grid layout uses simple row column tracking to organize emojis efficiently. The client-side design keeps the server unchanged and ensures fast, responsive performance. Future improvement could include emoji categories or search functionality within the current modular structure.
The second function is sentiment analysis. The core of this feature is to analyze the sentiment of the chat partner's message locally without analyzing the content we send ourselves. Implementing this feature is also divided into 3 main parts. First, we wrote a core function, analyze sentiment, in the sentiment tools.py file. In this file, we imported the NLTK and TextBlob libraries. Among them, TextBlob is responsible for calculating the sentiment polarity of the text, a value ranging from -1 to 1. while NLTK serves as an auxiliary natural language processing tool. After that, we label the messages according to artificially set ranges. For example, a polarity greater than 0.2 is judged as positive. Finally, this core function returns a label containing positive, neutral, negative, and the corresponding emoji based on the polarity and the set ranges. Next, we imported the core function from the sentiment tools.py file into the GUI file and controlled the on or off switch of this feature through a button. The control of the feature is mainly realized by the layout and the toggle sentiment method. The layout is responsible for creating the corresponding button widget on the interface, while toggle sentiment achieves the effect of switching the feature state by clicking the button. Specifically, when opening the client interface, the sentiment analysis feature is turned off by default. When enabled, the button background is light purple, and when disabled, it is dark purple. At the same time, the chat box will synchronously display the system prompt, sentiment analysis on or off. Finally, we added the proc function in the GUI, which is processing step before the chat message are displayed, responsible for feature trigger judgment and message processing. For example, we first filter out system or bot messages and only process user chat content, then split the messages line by line through the split method to extract valid sentences for analysis, and filter out the content we send ourselves to ensure only the other person's messages are analyzed. After that, we call the core function written at the beginning to get the return sentiment, label, and emoji, integrate them with the messages sent by the other party, and finally display them in the local chat box. The third function we added to our user interface is NLP, which is mainly used to summarize conversations and extract keywords from them. Particularly, the logic for NLP runs inside the client state machine, and the server simply relays messages without understanding them. We divided the implementation into three main blocks to make it functional. First, we created a separate Python file named NLP tool, where we mainly leverage the capabilities of Yake and Summy. These two libraries help us implement the two core functions, extract keywords, Yake, for keyword extraction, and summarize with Summy for conversation summarization. However, since these libraries are trained in English, we later found that the NLP function only works for English messages and cannot recognize Chinese or emojis. Additionally, since Summy and Yake's algorithms rely on things like text length and contextual relevance to identify key terms, they're actually better suited for long-term scenarios, not short-term sentence chats. But for chat systems, the conversation is always short, fragmented sentences, so the extracted keywords sometimes end up being less accurate and related to word frequency. After completing the core NLP functions, we imported these two functions into the GUI and enhanced the send button function to control the NLP features. Since there are already many buttons for game, ranking, bot, emoji, etc. on the interface, we choose to trigger NLP functions via /commands, such as /keywords for keyword extraction and /summary for conversation summarization. During testing, we found that the keyword result from NLP tool were not ideal. For example, extract keywords Yake kept extracting meaningless system words like request or chat. So we further processed the results in send button. We set up a ban list to filter these junk words. At the same time, to avoid losing too many valid keywords, we retained the first 5 keywords from the cleaned results, if any. If the clean results were empty, we took the 5 from the original results instead. Finally, we added the /summary and /keywords command NLP commands in chat UTIS, so these commands would appear in the pinned message for the chat room after users join.
In terms of the fourth function, we integrated a snake game into the existing chat system using Python's signature for the GUI and JSON for data exchange. Our implementation is adapted and rewritten from the snake game tutorial on Jigs4Jigs, but we reorganized the structure. We chose to run the snake game entirely inside the GUI class. The game runs in its own window, so chatting continues uninterrupted. This prevents blocking the client state machine, keeps gameplay smooth, and avoids interference with messaging. Therefore, only the ranking requires server communication. The leaderboard system tracks player scores in real time. When the game ends, the client sends the score to the server with this JSON format. The server updates its ranking dictionary and broadcasts the sorted list to all connected clients. This design ensures everyone sees live updates. We added a ranking button that opens a color-coded leaderboard showing top players with trophies for first, second, and third places. Key changes to the original code include extending the server's message handler to process game scores and leaderboard requests. We also modified the client GUI to include game and ranking buttons, ensuring the interface remains clean and functional. The main challenge was coordinating updates between the game, network, and interface. Using Ticketer's after methods for scheduling and checking for duplicate windows solved most issues. For future improvements, we would add score persistent to save rankings between server restarts and include more detailed player statistics. The system could also be extended to support multiple games with a shared ranking framework.
For the chatbot feature, we implemented client-side AI integration using DeepSeek's API. This design choice serves two key purposes. It avoids server modification and allows each user to control their own chatbot experience independently. The system centers around the chatbot class in chatbot.py. It connects to DeepSeek's API with configurable personalities, including friendly, professional, funny, and sarcastic modes. The class maintains conversation history to enable context-aware response, keeping the last 20 exchanges for continuity. Integration into the chat interface happens through GUI.py. We added two buttons, one to toggle the chatbot on and off, and another to select different personalities. The personality system adds flexibility through predefined prompt templates. Each personality changes the system message sent to the API, altering the bot's response style without modifying the core logic. Users can switch between personalities dynamically with visual confirmation in the chat window. When users type message with @chatbot, the system recognizes this trigger and routes the query to the AI instead of sending it as regular chat. The chatbot operates entirely on the client side. When it generates a response, the client broadcasts that reply to all users through the normal chat channels. This creates a seamless experience where everyone sees the bot's message as if they came from a regular participant. The chatbot implementation follows a clean separation between AI logic and interface management. The chatbot class handles all API communication and conversation state, while the GUI class manages user interactions and message routing. A key architectural design was maintaining conversation history on the client side. The system stores recent exchanges in a list, using them to provide context for subsequent queries. This enables more natural, continuous conversations while keeping the implementation simple and contained. Challenges included ensuring the bot's response integrated smoothly with the existing chat flow and preventing the conversation history from growing too large. We solved this by implementing reject pattern matching for @chatbot mentions and limiting history to 20 messages. For improvement, occasionally chatbot may respond slowly. Displaying a typing indicator on the page during responses can inform users that the chatbot is functioning normally. Moreover, the system could benefit from better error handling when the API is unavailable, more sophisticated context management, and the ability to customize or create new personalities. To wrap things up, let's break the system down into three main parts. First, the user interface. That's the part that interacts with you, shows messages and results, and polishes up the output mainly through functions such as layout, toggle, proc. Second, server communication. This part sends your input over, grabs the server's response, and makes sure data moves smoothly. Third, the function module. This is where the chatbot's logic lives, where data gets processed. All the core stuff happens here. And features like emojis, the snake game, NLP, chatbot, they are the little sub-threads tied to these main lines. They are what turned a basic chat tool into this multi-purpose platform we have now. Finally, a huge thank you to our professor for your guidance. That's all for our final project.